Okay, so we're going to talk about pair t-test today, but let's start off with the one sample and independent samples t-tests, because that will provide a structure for what we're going to do now. So the one sample, we had something t, lots of ratios in statistics. Ratio of something over something else. Does anyone remember what that was? It's more impressive if you just come up with it without anything else. And it's better for your memory too. You struggle to come up with an answer as opposed to just looking at it and saying, oh, that's it. That will help you much more in the long term. So we were like, I plotted something like this, right? And what were we hoping to learn about? Correlation, mean, variance, distribution.
The mean minus.
The mean. The mean. We're interested in learning about the mean. The one sample test we're interested in the question, is the mean equal to some value, right? You guys remember that? Is the mean equal to 700 milliliters? Is the mean equal to a 75 when I look and see how people's exam scores are distributed? Is the mean equal to 75, which it should be pretty close to, since 75 is the middle of the C range, and by definition, the C is supposed to be average. So the mean, which is average, should be the 75. So one sample is about, does the mean equal some value? So you said it's the mean
minus a certain amount.
Minus some value, minus 700 in our 700 milliliters example, right? We can put the units up if we want. Great. And what's it over?
Standard error.
Standard error of the mean. But what is our standard error of the mean for our one sample t-test?
Standard deviation squared. Oh wait, yeah.
Standard deviation squared.
Over the sample.
Over
N.
N.
And then with the square root over.
With the square root over it, right? And we can also represent this like this. So if you said standard deviation, and you put that over that, that works just fine too. Beautiful. Okay, so in this situation, we have our value, our sum value, 700, we're predicting it to be here. We estimate the population variance, and then knowing how population variance relates to the sampling distribution of the means, we create the standard error of the mean to say that we should see means mostly in here, right? And if we see means that are so far away from this, then we're going to say, whoops, let's reject the null hypothesis. This clearly isn't 700. It's more or less dependent, right? In the two sample, or independent, that's probably better than two sample, independent samples. What are we looking for? Not does this mean equal some particular specified value.
Does it equal another mean?
Does it equal another mean? So in that situation, we have two means, right? So we have one mean and maybe some other mean, and we're interested whether these two means really represent the same type of thing. And if they do represent the same thing, then what should this be? T equals?
The mean of the first one minus the mean of the second.
Mean of the first minus mean of the second, or x1 and x2. Groovy. And this should equal 0, right? Under the null hypothesis, the two means should be equal. So mean minus mean equals 0. Here, this should also be 0 under the null hypothesis. So the bigger those values get, the more likely it is that we're going to reject the null hypothesis. So what's in the denominator?
standard deviation of the first
Standard deviation of the first.
over there minus or plus the standard deviation, or I guess over n,
Over n.
which would be square root if you want to do it that way. Just the square root over the
I
n.
don't know if we want to do it that way.
So just the square root over the
Maybe
whole
let me, I'll rewrite this the way that it was originally stated. Because that might be,
standard deviation squared.
okay, variance.
And then all
And
that,
this would be of x and the n of x.
and all that in a square root. And then continue the square root and do a plus the standard deviation of the second squared.
Variance of y
Yep, over n.
over n, the number that we have for y. Right, that's exactly right. And what is this whole thing?
Covariance.
Standard error.
It's a standard error mean. It's just based on two estimates as opposed to one. So the first one, does the mean equal some value? The second one, do these two means equal one another? What's the paired sample t-test like? Paired samples. If this is, does one mean equal some particular value, and this is, does some mean equal another mean, what are we asking when we have a paired test?
Are they different from each other?
Or what different from one another?
The two outcomes, I guess.
The two outcomes.
Two averages, yeah.
Two averages, two means.
Yeah, from X and from Y.
So we can have something very similar to that, potentially, right? If we think about like what the methods types of designs would be, and let's just talk about the independent samples versus the paired samples. So the independent samples would be like, we get a bunch of schools, they all agree to participate in the anti-bullying experiment, and half of those schools are given the new anti-bullying treatment, and half of the schools are given the old anti-bullying treatment, right? You have different individuals in each school, in different schools, right? So you have a whole bunch of data points. You can look at the number of playground violence in this group of schools after the intervention, and the number of, or the mean number of violent interactions for this group of schools after the intervention. Does that make sense? So we basically have observations for each of the schools that are in our different sample. And from those samples, we are going to get some mean. And we can imagine something very much like this. I'm going to draw it a little bit bigger. So school 1, school 2, yeah, 1. I'm like LLs. CHOOL2. And we have some mean number of violent behaviors in each school. You can imagine sort of if we were plotting the violent behaviors per day, like there'd be a couple days with very little, a couple days with a lot, and a lot sort of in the middle, right? We're closer to the mean. So we have distributions like this for the two schools potentially. So we've got, what do we have? So number of violent behaviors and like times observed, not times observed, probability. Okay, so we've got school 1, school 2, or schools, because we've got multiple. So what would an equivalent type of design be if we used a paired sample? So with our independent samples, we had some group of schools that was randomly assigned to get the one intervention and some group of schools that were getting the other. We've already talked about one paired way that we could do this.
Two tests within the same school?
Do two tests within the same school. So instead of schools 1 and schools 2, we might have which would be the pre and which would be the post, hopefully. Pre, more violent, before the intervention, right? And post. Right? So we have the means that we observe. Now, if we think about what's in those distributions, we have different schools or different kids or different whatever. And here, like you can imagine this school. This is a higher SES. And we've got, let's say, lots of property tax. And you have a couple winners for the like Teacher of the Year awards for the national competition. And what's the equivalent over here? Which school in this group is most like that one? They're independent. Have we measured have we measured the socioeconomic status of the schools? No. Have we figured out how much property tax per student is going into those schools? No. Do we know, have we counted the number of winners? I mean, I said that there are these things at that school, but we haven't looked at any of that stuff. So because we haven't looked at any of that stuff, we have no idea of knowing which school in this group would be closest to this one. Does that make sense? So because of this, we don't know the schools here, or where it is. We have no way to easily compare two schools across situations. But here, you can imagine we have different schools, and we have one school, I'm going to represent it with a flower. The flower school, and it's over there. And here, the flower school is over here. Right? We can compare each school with itself. And we see that, flower school, although within the distribution, it seemed to do way better than average, it shifted down. Okay, what other schools do we have? We've got the knife school. Yeah, it's a bad knife, I don't know. And let's say the knife school is over here. And we've got, name some other symbols for me. Star school. Star. I'm thinking Lucky Charms, Clover, whatever, moons, diamond, oh sorry, I don't want to put that in exactly the same place, diamond. And you get the point. Each school has its pair, right? We've got before and after measures at all of the schools. And instead of being blind to oh yeah, this school is like this school over here, we can compare them directly. We have information that we can do that with over here. So think about it. Our question is about a difference between means, but if the means really are no different, then what does that suggest about all of the individual schools? If the means really were 0, so in this situation, imagine we've got something like this. Pre-test, post-test, just by looking at the data, you would say, it's not even going to be significant. We don't even need to run the tests. Yeah, it's the same thing, basically, right? So, if the star is here at one point, will the star be there at the next point?
Should.
It should be there, maybe.
No, I guess it could be different.
It could be different. It could be over here,
Scores, yeah.
right? But when we look at all of the schools, what's going to happen?
It's gradually gonna be the same.
Gradually going to be the same.
No.
No, that's exactly right, but I was just hoping you'd state it a little bit differently. It's going to vary, right? Some schools will go up, some schools will go down, right? But on average, what happens? Well, if on average the schools went down, we would expect that,
they're the same.
right? So if they're the same, if those distributions are the same basically, same means, same variance, what situation would lead to a situation like that? Some go up, some go down, but on average, oh, I thought you were going to say something. No. On average, there are more that go up, there are more that go down. The ups balance out the downs. What?
The test wasn't that effective.
Our manipulation wasn't that effective. So it looked like you were nodding your head. So I'll say it again. So on average, the scores go up, the scores go down. The scores that go up balance out with the scores that go down.
Scores that go up balance out.
Yes. Yeah. So the scores that go up, I mean, we wouldn't expect the schools to stay exactly the same. Because at one point in time, maybe something happened at this school and the kids are really rambunctious. And at some other point in time, they're on field trips, or the OMSI trip. Are any of you guys from LeGrand? So you know about the OMSI trip?
Yeah.
So the OMSI trip, they go down to the, what does OMSI stand for? Oregon Museum of Science and Industry, is that it? Yeah, cool. So the 5th graders, they go to this OMSI trip, and the teachers tell them, like, look, if you're bad, it's sort of like a Santa Claus or some other thing like that. If you're bad, the boogeyman's going to get you. If you're bad, you're not going to go to the OMSI trip. So maybe shortly before the OMSI trip is going, kids are acting a little bit better, right? So depending on things like that, we'll expect some to go up and some to go down. But if these distributions completely overlap, then the ups have got to balance out with the downs. And one of the cool things, if we have the same schools, or maybe not the same schools, the same people that we're looking at multiple times, right? I just said we're watching for playground activity, but we could look at individual students and see how the individual students are behaving on the playground, right? In that case, we'd be able to identify individual students within the different schools to see exactly how they change before and, or yeah, between the pre and the, you know, talking. We can see how they change after the intervention. So, instead of taking the difference between means, what else might we be able to do? Use the same words and mix it up. Be like Yoda. Yoda, be like. Instead of taking the difference of the means,
You can take the means of the differences.
yeah, you take, well, there's only going to be one mean, but yes, that's exactly right. But you did what I told you to, so thank you for listening. Instead of taking the difference between the means like we're doing up here, we can take the mean of the differences. So we have some difference between pre and post shamrock, and some difference between pre and post moon, and some difference between pre and post knife. We have a whole bunch of differences, right? So what if the null hypothesis is true? Should the mean of those differences be?
0.
0, that's exactly right. So we're saying that some mean should equal 0. What form of the t-test that we have up here does this look like? Or does that sound like?
One sample.
Sounds like one sample. So instead of having the mean of some values, we're going to have the mean of some differences. Minus we're going to keep it exactly like that. The 700 over here was the value that we expected, right? So what should the value over here be? 0. Well, that's easy. We can just get rid of that. What was the point? Okay, the point, if you're predicting a very specific difference, like imagine you've got, I don't know, are you guys, they still make Jolt? Yeah. Have you guys heard of Jolt? Jolt Coca-Cola, or not Jolt Coca-Cola, she's cursing. Jolt Cola. Twice the sugar, twice the caffeine. It was awesome. I used to love Jolt way back in the day. Anyway, so if you wanted to test that, right? Twice the difference, or twice the caffeine, you would have some value that you could potentially do if you had the Jolt regular and the Jolt non. Okay, so we have some mean of the differences, and what do you think the standard error of the mean is going to be? So again, we're going to have a standard error of the mean up there. What's that standard error of the mean going to be? It's going to look like one of these. Which one should it look like?
The one sample one?
The one sample one. Yes, yes it should. So let's start off with what we know. Square root of some stuff. What's that some stuff?
Standard deviation of the differences.
Standard deviation of the differences. Over.
N.
What does n represent? The sample size, so we have like 200 posts and 200 pre's and we've got 400? No.
Would you divide by 2?
Divide the 2, so we've got 400 total samples.
Divide by
And divide by 2, so we've got, I was going to say 4. 200?
I don't know.
How many pairs do we have? So if we had the 200 post and the 200 pre, we've got 400 total, and you said divide by 2, which will give us the number of pairs we have, right?
Yeah.
Ding, 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 good job. So the n, it's not going to be the number of total observations that we have, it's going to be the number of differences that we have. And there's one problem with the formula that we have up there as it is down. So compare. What's the difference? What should be fixed?
Squared.
Squared. Yes. That's it. Easy. Yeah. Well, I mean, if you can remember one, you can remember the other. It's the same thing. It's the same basic way. Here we only have a single sample. Here we have 2, but because things are paired, we can look at the differences for those pairs. So let's talk about why this would be so preferred over independent samples. Why do you guys think this is going to be so much more, I'll use the word powerful?
You can see the causation, I guess, or directly see the influence of one thing over another. There's less confounding variables.
There are less variables that could confound. And what do we do to avoid confounding a variable?
Increase sample size? Possibly.
No. Actually, completely no. Because imagine the situation, the situation that I talked about earlier in the class, right? Where I had 2 weights, and I had everyone pick up one weight with one hand and the other weight with the other one. Even if I massively increase that sample size, I have a confound, right? What is a confound? It's when an extraneous variable is correlated with the independent variable. And that's true regardless of whether I have a sample size 2. You have to have a sample size 2 where there can be a correlation, right? But that's true if I have a sample size of 2 or if I have a sample size of 200. That will still be confounded. And I still won't be able to make a good claim about causation, right? Because that means that my method was not internally valid. So internal validity has to be, or is about making strong claims of causation. And the only way that we have a really strong internally valid method is when our independent variable doesn't correlate with any extraneous variables. Maybe I should make another point too. So a lot of people, they think like, well, you know, internal validity, you can't have an internally valid test if you don't have construct validity. What's construct validity? Does anyone remember? Construct validity. Validity is something that is or does what it's supposed to be or do. And construct, what's that? You can think of like social constructionism, if that helps. Okay, let's go back to the beginning, or close to. How do you measure happiness? Not happy. She's not happy right now. Now she's happier. You're reasonably happy. You're okay. Anyone not really not happy? How am I operationalizing happiness right now?
Facial expression.
Facial expression, yeah, the size of your smile or lack thereof, right? So when I operationalize a variable, I define the things that I need to do to measure or manipulate that variable. So I operationalize happiness by saying I'm going to measure happiness by the size of someone's smile, right? Is the size of someone's smile, does that have construct validity if I want to measure the underlying construct of happiness? No, she says, no. Why not?
There's no concept.
There's no concept of happiness? You have no concept of happiness?
Set concept.
I'm not asking if there's a set concept. I'm just asking, can you measure someone's happiness by looking for smiles and frowns and things?
I think you have to measure other things around, like you can't measure happiness specifically, but you have to measure things around it, like smiles.
Smiles?
Dopamine levels or something, I don't know. Like you have to measure more than just one thing to kind of narrow it down. That makes sense.
It does. So how many of you see a friend, you're like, are you okay? Are you like, hold on, I have this way to test dopamine levels by swabbing your mouth. Let's see how you're doing. Or you see someone and they're like, oh, Dory! And you're like, what's your dopamine level right now? If you see someone like that, what do you think? They're happy. Is a smile not a way to judge someone's happiness? It is! Oh, thank goodness. That means it has construct validity, right? If looking at someone's smile is an indicator of whether they're happy or not, then smiles are actually measuring happiness. Now, I think I understand the problem. What's the problem with this measure of happiness? People can fake a smile. My grandma, I actually have no idea, but my grandma always smiled. Like the world is just great. Something bad happens, it's okay, it's all part of the plan. You know, just, wow. So maybe she's faking it, maybe she's always happy. Kind of hard to tell sometimes. But if you think about on average, like most people, you see someone coming out of an exam, they're like this, thinking they at least think that they kicked butt. Right? They're coming out of the exam like, oh, much. You're thinking they probably think that they didn't do too well. Funny thing is, people's thoughts about how they do on exams isn't always reflective of the truth, which is the same thing about smiles always reflecting. But we're not looking for something that's necessarily a perfect indicator of happiness. We're looking for something that's correlated with happiness, right? Because in most things that psychologists are interested in, there are no perfect indicators. Are you happy? You know, you can test your dopamine levels. Maybe you're not happy at all, but you've just taken some crystal meth. And your reuptake is like pushing the dopamine back out of the cell. No, we don't want it in here. And you're like, whoa! Right? So we look for things that are correlates. So let's say I want to, oh, no. I'm just going to use a test question.
No, feel free to.
No.
It's like, don't be shy.
It's just one, there's plenty on there.
There are plenty on there. Yeah. So, okay, this is a good one, I think. So when I was younger, my mom, she was a psych major, and she wanted to be a clinical psychologist. She was on her way. She was in a PsyD program, but she had me for a teenager, and she had to drop out. At least she got her master's. Anyway, when she was in her program, she had to do a whole... I owe her so much. So, in her program, she used to like bring home tests and test us kids and test our friends, the friends of the family's kids and stuff. And so on this one IQ test, there were questions like, what's the capital of Greece? What, Venus?
No, you're drunk. I don't know.
Go home, you're drunk. Let me see some memes.
Isn't it something with the
What is it?
Athens?
Athens, yes, yeah.
Hey.
Okay, what's the capital of Italy?
Venice. Rome.
Oh.
Is Venice in Italy?
What's the capital of Rome? No, I'm thinking the
Vatican.
Vatican, yeah. Vatican. But anyway, so there were questions like that.
I would feel that.
You're failing. That is actually a really culturally biased test. What culture is it biased towards? European, American, what type of stuff do you learn about if you go to an American public school? What history do you learn about? There wasn't a question like, what's the capital of Ethiopia? Anyone know that? I didn't think so. Why? It's because when you were in school, you were exposed to that type of information, right? So, if you're using this as an intelligence test, it's not necessarily measuring intelligence. I remember some other bizarre question. There was an octopus and a dog and a pelican and a shark. And the question was, which of these things doesn't belong? One of them's a bird, that doesn't belong. But only one of them's a fish, that doesn't belong. I ended up picking the octopus because I'd recently taken biology in which we were talking about vertebrates versus invertebrates, and I'm like, that's the only one without a spine. But I really have no clue. But presumably, if you live in different areas of the world or have recently been exposed to different things, that may not be the best indicator of intelligence. So let's say I give that intelligence test to you, or maybe I give you guys I think it's the Redden-Simmons intelligence test, which asks questions like, if you're playing the dozens, what are you doing? And the choices are like, you're staying up around the clock, you are gambling, you're insulting people's mothers, what?
I'm trying to remember.
So they designed this IQ test to combat some of the traditional interpretations of intelligence tests. So if you look traditionally, minorities have done poorly on traditional types of intelligence tests. And there are all sorts of majority people who are happy to tout out those statistics and say, see, whites, we're bright, yeah. So what happened? They designed this Redden-Simmons test that was supposed to be biased towards inner city people who are predominantly of minority status. And guess what group did better?
Minorities.
Minorities did. We white people so dumb. It depends on the test. It depends on the test. So if I were to use that test to measure your intelligence, and let's say I wanted to use some manipulation, and I'm going to, I don't know, give people caffeine before or after they take that, or not after, before they take that test to see if caffeine improves test performance. And I find out that maybe there's no relationship. Do I have an internally valid test? Do I have a constructly valid test?
Unless you test them twice, right? One person does it, like you do it before.
Well, I've got some people who are taking caffeine and other people who aren't. So I'm doing it between subjects.
Seems pretty good.
Seems pretty good. It is very good. But what type of good? Internal validity or construct validity?
Internal.
Internal validity. It's very good internally valid, right? You guys are having caffeine. You guys are not having caffeine. Maybe you wanted more information before you weighed in. Yes, I did randomly assign people to the caffeine versus non-caffeine conditions. If I didn't randomly assign people, all that internal validity goes away, right? So, high internal validity, low construct validity. It's not so much of an intelligence test as it is a test of have you been exposed to this culture. Does that make sense? So high internal validity, you're just not testing what you think you are. So we can have tests where we're not manipulating or measuring the things that we think they are that are complete or that have perfect internal validity, even though the construct validity is a complete mess. And we can also have things maybe that are constructed with high construct validity. So in figuring out whether people can tell the difference between weights, I have people lift weights and indicate yes or no. Is that a good way to see if people can tell the difference? Yeah, that's a great way to see if people can tell the difference, right? High construct validity, but if I have everyone lift the lighter weight or the heavier weight with the same hand, boom, all my internal validity is out the window. So the paired and independent samples, they can both be completely internally valid. So why is this one better? Okay, so let's pretend I'm a reasonably smart individual. I think that's a fair assumption. I have a PhD. Doesn't mean I'm really smart, but fairly okay. So if you give me a test, how would you expect me to perform? Well,
Depending on the test.
really, depending on the test. Like what test would I not do well?
Do like an accounting test.
If you gave me an accounting test, you forget that you
Yeah.
did accounting courses. That's right. But imagine me with, let's say, no quantum physics experience. And let's take some other person, and let's say that they're not quite so bright. How would we expect them to do on that quantum physics test that they also know very little about? Would we expect them to do better or worse than me? Worse, right? If you knew that this person had a good breakfast, and you knew that I didn't have a good breakfast, what would you predict about both of our scores? His will be better relative to whom?
Worse.
Himself.
Relative to himself. That's exactly right. And we know that he was well rested. Is that going to help him or hurt him? It's going to help him. Maybe in his spare time, he actually studies quantum physics. Is that going to help him or hurt him? So there are all these variables that could affect test performance. We've talked about a huge number of them, right? And a lot of those variables, if we're looking at the same person during multiple tests, most of those should be the same. I am I'm a member of X political party now. I was a member of X political party then. I have X number of siblings now. I had X number of siblings back then. I was brought up in this particular type of household now, and I was brought up in that particular type of household then. All of those things that can vary between individuals are the same for me. Now imagine I take some response time test. Have you guys played this game online, like could you duck the bullet? So there's this like flash game, and you hear a sound, bang, and then you have to click the button as fast as you can. And it starts off with things like, okay, the bullet's coming from a mile away. And so you hear bang, and you've got, I don't know how long, a couple seconds to hit the thing, and then your character moves and your brains don't get splattered. All right, so then it goes down to like half a mile, a quarter mile. So imagine I'm doing this. I'm playing this game. And I'm, however, fast. My mean is whatever my mean is. Do I vary from time to time? Why? Pardon?
Wait, never mind. I thought, never mind. I was just thinking the bullet's getting closer, but you were talking about like pressing it, not like
Yeah.
dying.
Because it's looking to see like how fast could you, or how close could you get to before the bullet. So unlike the guy on Kung Fu Hustle, like I can't do one of these Kung Fu Hustle great. But I could do, I don't know, whatever it was. And is my button press going to vary over time? So the answer was yes. Yeah, why? Maybe I get tired, oh, I've done this for so long, this really stinks. If I get distracted, ooh, what's that? So sometimes I'm going to be faster or slower. But what would you expect about my overall performance, like differences between my performance with myself and differences between my performance with other people? What differences should be larger? Other people. One of you guys in this classroom is probably going to be best at that. And one of you guys is probably going to be worse at that, right? And you're probably going to be consistently better. So if it's you, you might not win every single time if we did it for all of us, right? But on average, you'd be doing better than all of us. Yeah. And if you were the worst, we might not expect you to be the worst all the time, but on average. So what I'm saying is that when we have one individual doing something multiple times, we don't expect them to wiggle around that much. We expect them to wiggle around a bit, but not nearly as much as one person versus someone else who may have came from a very different background, who has different levels of myelination on their neurons and all of these other things that could influence how quickly they're responding or how much knowledge that they have or how well they can acquire and use information, right? So because we can take each person or each school or each whatever it is, what we're doing is we're controlling for all of those extraneous variables that remain constant from one person to another within the time that the test has been done. So yeah, my level of distraction is momentarily fluctuating. What am I going to have for dinner right now? Oh geez, the student was just frowning, right? So that's going to happen. However, my performance should vary a lot less than performance over the whole class at a time. And I see this in the students. You have some students who are consistently, or at least they look like they're consistently paying attention. They're nodding their heads or raising their hands, right? And you have others that look like they're not engaged. So there's a huge amount of variability between the students and what appears to be the level of attention that they're paying. But within the student, typically the same students that are participating one day are participating in other days, and vice versa. So because we can use the same person or the same schools, we are controlling for all of those extraneous variables, which means that there's going to be less variability in the differences here than we have here. And when there's less variance, what happens to the power? We've got two samples, right? High variance, low variance. Which is more powerful? The low variance situation. So by comparing each individual with themselves, we are throwing away tons and tons of variance. We don't have to worry about that, which which makes it so much more powerful. Okay, I'm done for today. Do you guys have questions? Or should we leave 5 minutes early? You guys can hang out if you want. I'll hang around for a little bit until everyone leaves.